All right. So we could do something with an interaction term like that. We could look at our coefficients. If we wanted to, we could do a prediction, again, for this same person, and we would have a slightly different predicted value. I think we did the interpretation on that coefficient over on the iPad. And we can have more complex examples. So we could have added interaction terms to allow more predictors to vary together. So we could use 2 interaction terms here. So I think my model numbering has gotten off now, but I'm going to try and predict the highest year of school completed based on the highest year of school completed by the father times age numeric. So I'm going to let those 2 things vary together, plus the highest year of school completed father times the born in US. So those 2 things can vary together, plus age numeric times born in US, data equal GSS. So we're going to have a ton of interaction terms in here. So let's run this and then look at the summary. Wow, I need to run that again so that I can actually see it. Okay, so I've got my 3 coefficients just by themselves, and then I've got 3 interaction effects. It looks to me like this interaction that we had before, that one is not significant. So this is kind of a, the choose and assess. Since that one's not significant, maybe I want to pull that one out to make it a little bit easier to understand what's going on. So I'll pull out the age numeric. Let's see. I think if I just take off this term, I think I'll still get everything else that I wanted. Let's check. I can always add things back in if I want it. Yes, 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 I've got those 3, and then I've got these 2 interactions, and they're significant. Interestingly, born in the US is not significant, but the interaction between born in the US and age numeric is significant. So now we've got 2 interaction effects, and we could think about how to interpret those. And maybe I'll go back to the iPad to do that. Okay, so here we are. We have a really complicated model. We could write it all out. Y hat 9.93 plus 0.4 highest father plus 0.4, I'll just call it US, plus, oh, am I getting off here? Let's see. That's that one. Should be 0.27 minus 0.02 times age minus 0.16 times, I'm just going to call it H times U, maybe colon U, plus 0.04 U times A. So we've got a really complicated model. Because one of our variables is categorical with just 2 categories, my inclination is to plug in the 0s and 1s. So let's do born in US. Let's do the yes one first. So that would be y hat 9.93 plus 0.4 times highest father plus 0.27 times 1 is itself, minus 0.02 times age. And at this point, my old version of this video had a mistake in it. So I'm re-recording it and I'll re-upload it with the correct ending. So it was right up to here, and now we're just gonna continue. So we've got the minus 0.02 times age, minus 0.16 times, and then we've got the interaction between highest year of school completed father and U, born in the US, and we're plugging in 1 for U, so that'll be times H. And then we'll do plus 0.04 times 1 times A, so then we'll have times A. And now we need to combine a ton of terms together. So I'm going to combine together that 9.93 plus the 0.27. I'm going to combine the 0.4 minus 0.16 times highest father. And then I'll combine the negative 0.02 plus 0.04 times age. So that will be 10.2 plus 0.24 times highest father plus 0.02 times age. And that'll be the equation for the born in the US. And then let's do the same thing for born in US no. So I've got my y hat, I've got the 9.93 plus 0.4 times highest father plus 0.27 times US, which is 0, so that'll drop away, minus 0.02 times age, minus 0.16 times the interaction of father's education and you, plug in 0, so that term is going to drop away, and the same thing for my last term. So actually, my complete equation for born in the US no is just this one. And then the question is, what's the geometric shape of this model? So we have two things, so it's going to be 2. And we'll have to think about, is it flat planes or warped planes? And in this case, they are both flat planes. So it's 2 flat planes. Are they parallel or not? They're non-parallel because the slopes are different. So the slope for highest father is different. We've got a larger slope for the people who were born in the US. And then the slope for age is different. And in this case, for people who were born in the US, it's a positive slope. And for those who were not born in the US, it's a negative slope. So it actually changes the directionality of that coefficient. So let's see if I can draw kind of an ugly 3D approximation of this. So we could imagine we've got years of school, we've got father's years of school, and we've got age, and then we've got points that are existing in 3-dimensional space. And then I'm going to try and draw some planes. So maybe this is one plane in 3-dimensional space, and then we'll call this one another plane. And I'm going to shade these in with the highlighter, so maybe they'll look more like planes. There's one. And here's the other one. Not to scale, but they have different slopes in both directions. So they're not parallel planes. They're 2 non-parallel planes, but they are flat.